well, we'll be explaining a little bit what we're gonna be doing. So what we're doing here is doing a bypass signal. In this case, simulating the signal that is coming out of from the computer to control any ignition component in this case. But also we're simulating the signal from some sensors and sending that back to the computer. So in this case, we gotta be very careful because we don't want to be burning computers or burning any components. So my suggestion is do not use any jumper, directly wired, because how I do it all the time is, and I have never burned any computer, is using the test light. My test light is drawing about 300 milliamps. You can build your own test light out of from a little light bulb from the license plate illumination. So those bulbs are the same that the one my test light has. So basically, if the computer is sending 5 volts, we're gonna say to control this here on this horn that I have here. If I'm connected to battery positive, I'm sending 12 volts, but the computer only sends 5. And I'm gonna damage anything? No, I won't, because my test light is absorbing the amperage, and it doesn't matter if that one say 12 volts. It won't burn the component for sure. It won't. I've been doing those for years. Okay, same thing, when I was doing the map sensor is sending max 0 to 5 volts, and I was sending 12 volts. And on my testing I'm doing here, is that gonna damage the computer? No, it won't. The computer is limiting inside the amount of current that one is gonna draw in the test light too. So we gotta make sure, we use a test light and do not use a jumper. If you use a jumper directly, you really gotta make sure more or 3 times make sure what you're doing, because that's the point, when current is not limited. So we're not limiting the amount of amperage is gonna be drawing that component when we jump it directly. So I just wanted to make sure, about that one, because it's a big difference using a jumper and using the test light. So hope it helps someone, but be careful with those testing. Using test light, I haven't burned anything. There are only 2 connectors that can be checked on the upside here on the distributor, which will be this black and yellow, the pink one, which will be key on, engine off, or key on, engine running. It should have a battery voltage here, high voltage. So this one is the power is shared inside to the ignition control module, or igniter, how they call the Japanese, with the ignition coil. Okay, so the ignition control module needs a power and ground, and the control is basically a switch internal, like this is a mini computer, which computer to computer, how they communicate, or one of them has to control the other one. In this case will be the PCM, the one will be controlling the ignition control module. One of the 2 computers has to produce the voltage, high voltage, 5 volts, 7, 9, or 12, and the other one has to apply the ground. So in this case, what I know is usually the ignition control module is producing the voltage. For that to happen, this one needs power and ground. Power, ground, and this one send voltage out of here to the computer. When the computer meets the criteria, cam and crank applies ground on it, so that is to trigger the coil. When that happens, this ground is transferred here. Primary output control, like a switch, internal, which ultimately ground the coil. When that occurs, it grounds the coil, is produced and it released, is produced here on the distributor. So I'm gonna be checking on the ignition wire when we do that. So basically I'm gonna be checking for power on this, and then here we're gonna be applying ground
with the test light, and that ground is gonna travel through here. I'm gonna be doing the work of the PCN here. Okay, basically those are the only two pins I can check on this one. The other one are two pins, 3 and 4, yellow and black. Those are for that cylinder position sensor, which is basically a cam position sensor, which is telling the computer when the cylinder number 1 is on compression, so that way the computer can start firing the injector on compression cylinder number 1 and firing order. So we're gonna move now to the testing. Okay, right now I will be checking here the power. I'm gonna be looking at this one here. I'm gonna be touching right now on the black and yellow, which is the pin number 1, battery voltage low 1.6. You can see right here. Okay, this is voltage coming in, so I will be showing you the test light, that one. I have the test light connected to ground on the battery, and then you can see here test light. Okay, and then zoom on that one. We'll be taking this out a little bit here, right here, maybe that one. Right here, so we can see I'm on the top here. So I am test light on, see, and voltage is battery voltage. So now I'm gonna move my pin to this one here, pin number 2, yellow and green. That is the signal from the computer to trigger the igniter or the ignition control module. So basically the module is producing the voltage, high voltage, and let's see how much is that one. We'll apply this. I want to check here. It's producing same voltage coming in, voltage going out. You can see that here. I'll bring that one here, so that way we can see here. You see 10.9 volts I have right now. Battery is weak, so that is same voltage. The computer is coming in to the, that is the voltage is produced. And on this pin, what I will be doing is I will be tapping on it, on the yellow and green. I will do the job the computer does. So I'm connected to a ground right now on the on the battery ground right now on the test light. And when I do this, we're gonna produce the voltage. I got the key on and engine key on. We can see every time I touch this one here, okay, I already have here the engine, the distributor pointing to the cylinder number 4. So that way when I touch that one, the coil internally is producing the spark and it's going through the wire. So as we can see here, capable of producing more than 30 kV. This is a bypass. Basically that means we have from here over, we have wheel igniter with coil, wires, and we have good spark. And running, I'm connected to the signal of control wire coming from the computer to the ignition control module. You can see how that one is blinking on the ground side, and the red is maintaining all the time. So control side to the ignition coil, and I will be connected to right now to the power black and yellow pin number 1, so we can check, see here, it illuminates on red. So power side, I'm gonna turn off the engine. You will see only power coming out, waiting for the computer to ground that one. Here, key on, and this is, you see, power only on the pin 2 of the distributor, which is yellow and green. So the module is producing the voltage, waiting for the computer to ground it and trigger the ignition coil. Now I will be doing some, we'll be having the test light connected to a ground on one side, and I'm gonna be touching here power, verify that one is connected. I will be disconnecting the ignition wire and checking for a spark, giving a patch to ground to the test light. So gotta be careful here when I'm doing this. So at that point the spark has a place where to go. We're checking the amount of spark you can jump to. And then I will connect it back. Sorry for the shaking here. So how we're checking for spark and sending the spark to ground, so that way we don't damage the coil. Okay, basically I'm connected here to the map sensor. 3-pin connector, same thing with TPS, power, ground, and signal. Okay, what I'm gonna be doing is checking for power here. So I have here the scope, so I'm gonna touch on that one. We have 5.08 volts on the power side. The computer is sending 5 volts power to the sensor. So move to the pin on the middle. Okay, we have 0.03 volts, so pretty much this one is 30 millivolts. Under 100 millivolts is acceptable on the ground side. Okay, and now we're gonna move to the signal wire. Okay, the third pin, this is red with something there. Okay, key on, engine off, plug in. We have 2.9 volt, almost 3 volts. So the computer is sending about 5 volt reference to this. It's not reference, they call bias voltage. And then when the sensor is plugging, it's dropping that voltage. So I will unplug this one, we'll see how that changes. Okay, I unplugged the sensor, and now we can see we have 4.7 volts. I don't have a good connection here, we got a solid connection now. Okay, so at this point, if the manufacturer is telling me on the flow charts to go and check for wire, disconnect the wires, check for resistance and on the computer here and there, at this point we already know this wire is okay, the computer is okay, but still gonna do the bypass test right now. So what I will be doing is, with this unplugged, I will be connecting my test light to a ground. I have it connected to a ground. You can see that one illuminates. Okay, and then now I will drop that voltage to ground. Pretty much will be I will be dropping this voltage to ground. Okay, when I touch it here, I want you to go to about 0. Okay, release it. Okay, so that means this wire is good from here to the computer. Now I'm gonna connect it to a power side, a test light, and then I will send high voltage. I'm connected at the battery of the car, and right here, I'm gonna see here, connected to positive. So we see there, it's reading about 5.9, equal to 12 or something like that. I'm sure I won't damage this. I have done this too many times, so I know I'm not damaging the computer here. Okay, so what that tell me, the computer is capable of reading low and high voltage. Not the computer. At this moment, I'm just checking here at the sensor with the scope. I'm gonna move right now to the scanner. The scanner, see, I only have the map sensor there. So at this point, this one is unplugged. Okay, I'm connected on the battery positive right now. So we're gonna test for that one. We're gonna see that one go higher. 4.96. See? Release. Okay. Now I'm gonna be connected to ground side on the test light, and that one should have to go to close to 0. Okay. Connected there. Release. Okay. What's the purpose of this test? Test the wire, integrity of the wire. What this tell me? The wire from here to the computer is good. Computer is good, it's reading the changes. So basically I don't have an open or short wire. At least I know right now if it will be intermittently. But instead of disconnecting the computer and checking for this wire for resistance, we can see it here, it's good. If you want to check the wire, you can, you know. But at this point, I will be recommending, instead of checking with a ohm meter like they wanted, I will be unplugging here on the computer, and I will be sending power through here, disconnecting the computer, and plugging there a test light. So that way I will be loading the circuit.
Well, here are the bypass I was doing. As we can see, on the distributor, there are 4 connectors: pins, pin 1, pin 2, pin, pin, pin 3, and pin 4. So basically, the black and yellow is the one is power with key on, engine off, or key on, engine running. So this power is shared inside the distributor, in between the ignition control module, igniter, how they call the Japanese here, inside this power here to the ignition coil. Okay, so the ignition control module needs power and ground. Okay, the ground is constant on the body of the ignition distributor. Okay, so the other 2 wires, one is gonna be the input and the other one is gonna be the output. So how does input work? Okay, so when the module has constant ground and power here, the module should produce some voltage here on the pin 2, yellow and green. Okay, that voltage varies from vehicle to vehicle. I have seen those 6 volts, 7, 8, 9, 12, 14 system voltage. However, the most important thing is this module should produce some voltage, and then the other important thing is the computer is gonna ground that one. You wanted to see that one goes to close to 0 when the computer does that. Okay, so at this point I'm doing my bypass here. I was connected to the yellow and green, and I was connected to ground, battery ground, my test light. So when I was touching here, I was pulling this voltage down to 0 volts, pretty much. By doing the work that the computer will be doing, and we saw that one. So on the primary output control here, the signal was going out the ground, applying that ground to the coil, ignition coil on the ground side. When we release that, the secondary sparks occur, and the spark should be on good, good spark should be jumping about 3/4 of an inch, so about 19 millimeters, with steady and light blue color. Okay, so there is inside this, so the distributor. So at this point we were testing, if we wouldn't have a spark, we know our problem from here to over here, everything is good. So we gotta focus back here on this wire to the computer, and then crank position sensor, and also this the cylinder position sensor. So this cylinder position sensor, its job is to report to the computer when the cylinder number 1 is at TDC compression, and then that way the computer can start firing the injectors in order, um, sequential injection they call in the firing order. Okay, there have been known some failures for this sensor too. I'm gonna go back through those. For example, this is one of the failures for that sensor. The DTC 1381 affected the Echo 98-201 and Civics 96 to 2000. Okay, this service is coming directly from Honda, and what they're talking about is about these coils.
No, I think it was my crash sometime. My video card. Well, it came back. Well, okay. So what usually fails in this coil shield, the plastic is in between the coil. So what happened with that one, that they are giving the service bulletin? If this code is being set, the first thing they wanted we to check is that remove the cap, distributor cap, and then inspect for that one to be in the correct installation, and it's not missing or is installed correctly. Okay, that is the first step, because it's what happens supposedly that there is a electrical interference which is picked up by the coil or from the coil to that sensor, and then that noise is transfers to the wires and the computer. That's a misinterpretation. Gonna go back to here. This is that coil, and basically general description how this occurred, how this worked, and everything here. So you can read here. So if a CYP sensor pulse and signal are detected in a normal number of time due to a noise or malfunction is detected, DTC is stored. Okay, so that is why they want me to check that one criteria all the time. Gonna move to something different, another subject here. We can see this one when this is it's been very common on the engine stalled while driving, will restart and does not set any code. Okay, we know this. Whoever has been working for a long time on this Honda, we know that the distributor can do that. Ignition coil, the distributor, igniter, main relay, the one it gives power to the computer, and the fuel pump. But it's been known like that too, the ignition switch. So here they are telling us they have a recall for that one. So basically the dealer has been fixing those without charging the customer, and they are saying this too. There have been cases where the dealers say the recall was performed and the ignition switch failed again. So apparently the theory behind it is what happened is inside the ignition switch, the contacts, when you get hot, they open, and that's what it is. Gonna go to another here. No start, no spark. check engine light come on for 2 seconds. We're still in Hondas here, and goes out. Okay, check engine light come on for 2 seconds and goes out. So this is a proof out that computer is alive. So check engine light come on, go off. Okay, computer at least is alive. Also the immobilizer light come on for 2 seconds and go out. Okay, so you recognize the key and then say fine, give the okay to engine to start. Verify that the coil and igniter have good battery voltage on the black and yellow wire, the pink one. This is the one we're checking on the wiring diagram. Next, verify that the yellow-green wire from the igniter to the engine control module has 6 volts or higher. So this is the one the module is producing that voltage. This voltage is sent from the igniter and engine control module. ECM will push that one to ground to create a spark. If the voltage is okay, use a DeWalt meter or lab scope and backprobe the yellow green wire. Look for 10 to 12 volts degrees of DeWalt cranking on 4-cylinder scale or nice square digital signal on lab scope. Okay, we're gonna say that is okay. Now we move to the other step. We still do not have a spark. The DeWalt is correct, or square wave digital signal is correct. Check the coil negative. We have to open the stereo cap and it should have the same DeWalt reading or a primary ignition pattern. If there is no DeWalt on the negative, the igniter is faulty. If there is a low DeWalt on coil negative, the coil and igniter are faulty. Always inspect the faulty stereo cap. Okay, and they are telling us here too, check for that little shield. Don't forget to install or do not lose that coil, the little shield there. Okay, so this is about the Honda. So we're gonna do check on another vehicle soon. It's gonna be a Toyota.